Welcome to qnawire.
So for a crude estimate, we're going to model the hurricane as a cylinder of air. And so here the mass, which mass of any object would be equaling the density times the volume. This would be equaling the density times pi r squared times the height of the cylinder, or the height of the hurricane. And so this would be the density of air, 1.3 kilograms per cubic meter, multiplied by pi, multiplied by 8.5 times 10 to the fourth meters, quantity squared, and then multiplied by 4.5 times 10 to the third meters. And we find that the mass of this column of air is going to be 1.328 times 10 to the 14th kilograms. So this would be for the hurricane. And then for part A, when we want to find the kinetic energy of the hurricane, this would be 1/2 times the moment of inertia times omega squared. And so this would be the rotational kinetic energy. This would be equaling 1/2 times 1/2 mr squared, moment of inertia for a cylinder, multiplied by the velocity at the edge of the hurricane divided by the radius of the hurricane squared. And this is equaling the mass of the hurricane times the velocity at the edge squared over 4. And so the kinetic energy would be equaling 1/4 times the mass of 1.328 times 10 to the 14th kilograms, multiplied by 120 kilometers per hour. We're going to multiply this. For every 1 meter per second, there are 3.6 kilometers per hour. This entire quantity is squared, and we find that the kinetic energy of the rotational kinetic energy of this hurricane is equaling 3.69 times 10 to the 16th joules. This would be your answer for part A. For part B, they want us to find the angular momentum. This would be the moment of inertia times the angular velocity. This would be equaling 1/2 mr squared. And then we're going to multiply this by the velocity at the edge divided by r, plugging in for the angular velocity. And so this would equal 1/2 mr times the velocity at the edge. And we can solve. So the angular momentum would be 1/2 times the mass of 1.328 times 10 to the 24th kilograms, multiplied by 8.5 times 10 to the 4th meters, and then multiplied by 120 kilometers per hour. And we're going to multiply this by, again, 1 meter per second for every 3.6 kilometers per hour. And so the angular momentum L is equaling 2.21 times 10 to the 20th kilograms meters squared per second. This would be our final answer for part B. That is the end of the solution. Thank you for watching.